Good morning. This is Vivek Bhatnagar. Today I'll be talking about the subject MC 104, that is software engineering. So in this introduction to software engineering, I'll be going with the course content, that is software engineering, the evolve of role of software, the factor contributing to the crisis, then a brief definition about the software and the software engineering, right? Software engineering problems and characteristics of the software. So the first question arises, why software engineering? Because the changes for the nature and the complexity, and everybody's want to go with the improvement. So for the improvement, we are ready for the change. So what are the factors that go with the software? Because as we talk about the software, the industry is going to be the crisis. The crisis is like the problem associated with the software industry is termed as the software crisis. So the advent of software in India has been started around 1941 onwards, as it is mentioned. So what kind of problems we are facing with? As I just go with it, the crisis related with the problem associated with the software industry is termed as software crisis. So what are the factors that contributes it? The first is very lately, costly and unreliable, and software was quite expensive because all the time it is labor extensive and labor is involved. So now as per the report, as it is mentioned in the Pankaj Jalote also, the IBM report, the 31% of projects has got cancelled and 53% was over budget and 189% was like overestimated. So out of 100 it was reached at 94. So as you can see from this slide, the success rate was quite negligible and the failure rate was approximately arises because we were unable to deliver the software in time. So it was lately, costly and unreliable. So as you can see from this figure, you can just well see the hardware and the software ratio is tremendously goes down. As you can see from 1960 onwards, we are tremendously decreasing it. So now again for the evolving role of software, as you can see why it is so, why the crisis came, right? So it can be the cost is high, or we were not able to deliver the software in time, or at that time we were unable to get the good number of software engineers, or what was there just to contribute the factors that come with the problem termed as crisis, right? And why do we have difficulties in measuring progress of our software development? Why it is so? So what are the factors that contributing to the software crisis? Like we were unable to delivering the larger problem, or at that time we were not having a good number of software engineers at that time, and of course I should say at that time it was increasing of a skill shortage because we were not having to finding the skilled person at that time. And of course if it could have been happened, then the productivity rate can be low. So we are moving towards the low cost, high quality and the small cycle of time. So here are some examples how we can go up with the terms called crisis. So the very famous problem was there, the Y2K problem, that is the year 2 digit problem. For example, if the year 1984 will be there, then you are able to write 84. It could be 1989, you can write 89. Then what would happen if the year 2000 came? How you will able to write, go with this year to 2 digit problem. So when the year 2000 came, we were unable to go with the how to write it. So this was termed as a problem regardless of our software, right? So this could be the first problem we termed in the crisis. Second, most of the financial software you might have think it has been fraud from the ATM. You have your ATM but somebody has cloned your ATM, and you have your ATM but the money has been stolen. So most of the financial transaction has been failed again, or you can say the crash due to the again financial software or the failure of a software. So again it is termed as a crisis problem, software crisis problem. Third, as the Windows XP was launched in 25th October 2001, so at that time the 2 patches were not sent to the customer, those who have bought the windows at that time. So what is the users to buy a genuine product for the window? Because once you will be getting to install the window XP, say the license software, so you will be get updated from the malicious filter, K7 securities, other features once you connect with the internet. So those persons who buy the window at that time, they were not able to get the 2 security patches at that time. So again it was a fault of a software, right? So they rectified the problem, they sent the same 18 MB patch to the persons, those who have buy the general product at that time. So again it was a failure with the software, right? So most of the things, with the example I have discussed with the crisis problem along with some examples you have seen on my PPT. Then I am moving across with some solution that why we are moving towards a word called software engineering, because we are facing a problem with the software, then there has to be something in plus so that we can move across so called software engineering. So as everybody know, the software, there are so many definitions, it is written on the book. The definitions can be the data required to get a result from the machine, say step by step instruction to solution is also a software, so many definitions that has been written on a book. But somewhere if I am talking about the professional definition of a software, then it is a computer program and along with some associated documentation and operating procedure applied on it. So software is termed as the program plus the documentation and the operating procedure applied on it. Say for example, a bundle of program is to be there, for example antivirus, how to install an antivirus, then for that you might be having some documentation for that, and after documentation once you open it the CD you will having the operating procedure like step 1 open the CD, step 2 insert it, step 3 so on, then serial key and so on. So this is how we are talking about a professional definition of a software. So something like that if I would like to go with, like I am moving across with the software engineering, then the picture could be like the diagram which I am showing for the manual or operation manual. So it should be the systematic development should be there, so that I can go with some analysis and along with some design. Then I am talking about the implementation for the same, it means the coding plus testing should be there. Then after I can move across with the documentation manual with respect to the my software engineering. So if I am talking about in software, then there must be some characteristics for that, like the software is developed or engineered but not manufactured, so, right? Somebody have to made it, so it is developed or engineered but not manufactured. So and apart from the software we can make use of the reusability of a component. Suppose you have made a product A, then you want to make a product B, right? So if you want to make a product B which is similar to A, then we can make use of content A with respect to B, right? So we can reuse the code component for that, right? Somewhere it is called, then software is flexible, right? And one more thing, it does not grow old, right? It needs to be updated. So it means the software does not wear out, right? So now from the software we have talked about, now I am moving across with the term, as I told you, the software engineering, in which if I am talking about a problem and how to solve a problem, in which we are talking about the theory as well as the practical also. So for the same way there must be some tools, techniques, some technology should be there, so that I can enhance the problem. Because I am talking about software engineering, it means problem solving activity that has to be solve the specific problem of a client or the customer. So customer is always seeking for a problem. Say for example, I am talking about a computer science which is a subject, a base subject, and in which it is having the theory as well as the some computer functions. So if I am talking about the basic and practicals, then I am talking about the software engineering. So there must be having some tools, technology to solve a specific problem. So if so I should say, if it is written, the process of solving customers problem by the systematic development and evolution of a large high quality software system within the cost, time and other constraint. So it is a systematic development to the operation, maintenance and retirement of a software, right. So it should be a systematic process, right, as systematic is development, operation, maintenance and retirement of a software I am talking about. So if it is an systematic development, then if software engineering is to be there, then there must be a problem with the software engineering also, right. So first problem was there, the problem of scale. So in a problem of scale is like the same should be applicable for the small project as well as for the large project. But what is happening for the small project, the rules and regulations are different, and for large one it is different. But the problem should be the same set of rules should be applicable for the small as well as for the large project. But in reality it does not happen. For example, if I would like to go with how many students are there in MCA first semester, right. So I can count easily how many students are be there in an MCA first semester, right. But the same way, if it's to be there, how many students are there in MMDU Malana for first year. So MMDU Malana is having a big scale, so many departments are been there. So I have to deploy, and every department I have to deploy one person who will be able to count out how many students are there for the first year, right. So the rules are different for the large project and the rules are vary for the small project. Then the second is the cost, schedule and quality. As I told you, it is the labor extensive all the time. We are talking about the labor involved, because how many persons are working on one project for how many months. So it means I am talking about one person working on one project for how many months. So all the time it is labor extensive work, right. Because why it is so? Because we have to count the total number of persons months spent in the project, that comes in persons month. One person working on one project for how many months. Then third one is the problem of consistency. Again, for the software engineering we want low cost, high quality and small cycle of time. That is an objective, or you can say the optimal solution. Again, for optimality is the low cost, high quality and the small cycle of time. Then every cycle the software should give the consistent result, right. So for consistency, for example, if I should go with one example, you have an say tube light which is of a Philips brand tube light. So then Philips has fixed and consistent criteria that it will blow 8000 hours, right. Otherwise you will get guarantee of 1 year. So on contrary, if you are able to buy the tube light which is of a Chinese tube light, so they won't provide you any guarantee because it will not blow at least 8000 hours. So because the consistent criteria for that Chinese tube light is not fixed, right. On contrary, if it could be of the Philips branded tube light, then they have fixed and consistent criteria that at least it will blow 8000 hours. Otherwise the customer should get warranty of 1 year, right. So these such kind of problems I am discussed with the software engineering too. So for the today lecture I have gone with the crisis, software engineering problem, then characteristics, and this is end up with this lecture for this today. Thank you.